This is a quick video over some graphing skills. So the first thing we're going to look at is the data table. That's a bright color. Data table is a really easy thing. The first thing that we have to always do with our table is give it a title. Give a title for each column. So for the data table that we're going to do, one column is going to be distance. The other one is going to be time. Now, one thing we need to be sure to do for our column headings is to give everything a unit. So distance is going to be measured in meters. And over here for time, we have to be sure to include a unit. The unit for time is going to be, obviously, seconds. And so, for each data piece that you have, you're going to fill in the table with the data that you take in both distance and time. So for distance, if it comes down to it, and I write down 1 meter, and then say it took 40 seconds to go 1 meter. These two entries are not correct. Okay, they are wrong. What we don't need here are the units. Those are unnecessary. We don't have to put that. As long as we have our unit up here, we don't need to worry about putting the unit in the table. This is a really easy thing for a data table. It's a nice way to take all of our observations and organize them. Basically what we saw when we saw it in this case. Once we have a data table, we move on to graphing. Here's an example data table. It's a little bit different than the one that we just did, but it's fine. Each thing still has a title, and each thing still has a unit. So we're all good. So as we look at graphs, we need a few things. The first is a title. This one, pretty simple, is just going to be distance versus time. That's all we need to do for the title. So we'll put that over here. Thing 1 is the title. The next thing that we need to do is label our axes. So for us, the y-axis we're going to put as time. Sorry, the x-axis we're going to put down as time, measured in seconds. So we're going to take the title for this column and label an axis with it. For this one, we're going to label it distance, and it's going to be in meters. So again, we're going to take the title of each column and make that our axes label. I'll write that down too. The next thing that we have to do is give ourselves a scale. Now here we're going from 1 to 10 in time, and we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places. So we'll go 0, 1 second, 2 seconds, all the way down the line. It's a very convenient interval. We're going to do the same thing for distance, and we see that distance we're going from 12 to 75. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just to make things easy on ourselves, we'll go by tens. So 10, 20, 30, 40, 50, 60, 70, 80, we don't know how to count, 90, and 100. Very easy scale. So 3, scale our axes. So we have a tile, we've labeled our axes, and we've scaled our axes. All that's left for us to do is graph. We'll go ahead and do that on the next page, but as a note, this is going to be my ordered pair. So that circled ordered pair right there is going to be 1, 12. So I'd come over here and go 1 and get here. We just did 1, 12. The second one is going to be 2, 19. The third one is going to be 3, 26. The fourth one is going to be 4, 33. The fifth one is going to be 5, 40. And again, it's just simple graphing. 6 is going to be 45. 7 is going to go with 54. 8 is going to go with 61. 9 is going to go with 70. And 10 is going to go with 75. Now we've graphed our data. Once we graph our data, we're going to move on to best fit line. We'll move over to that slide real quick and talk about what we need in a best fit line. So, here's a best fit line for our data. Oops, sorry about that. Best fit line for our data. Now, I want you to notice this right here. Our best fit line does not have to go through the origin. That's a thing to remember. A lot of people make that mistake. It needs to fit the data. And if the data don't have it going through the origin, like this one, has it crossing somewhere around 5, then we don't need to have our line go through the origin. 0, 0 wasn't a point. It doesn't have to go through the origin. Second thing, it fits the average of our data. So looking at our best fit line, I've got some points above and I've got some points below. It's sort of the average of what's going on. It's a good representation of all of our data. So, it doesn't have to go through the origin. It fits the average of our data. One of the more important things is that it is a straight line. You're going to need to use a ruler or a straight edge of some point, but what we really need is a very straight line. Once we've drawn the line of best fit, we have to find the slope and the equation for a line. We'll talk about how to do that a little bit more in class and what the significance of it is. After you draw the best fit line, though, you ignore the data points. You will no longer use these data points for anything else after you draw the best fit line. They're dead. They're no longer useful. We say that our best fit line now represents all of our data, and we don't need data points anymore. That's all we have to say about graphing. So.